Measure airflow like a pro with the heating, ventilation, and air conditioning temperature rise formula to calculate cubic feet per minute and hit the target airflow per ton of capacity for air conditioning systems, so your system delivers peak comfort, efficiency, and reliability. To calculate airflow using the temperature rise method, you use Q equals 1.08 times CFM times delta T for heating mode and 1.08 times CFM times delta T equals sensible capacity for cooling mode. Then solve for CFM by dividing sensible capacity by 1.08 times delta T. The 1.08 constant accounts for air density and specific heat at standard indoor conditions. For airflow per ton, the expert target is 400 cubic feet per minute per ton, with an acceptable range of 350 to 425 cubic feet per minute per ton, depending on dehumidification priorities and duct static pressure limits. When measuring, use a high-quality digital thermometer with fast response and measure the return air temperature and the supply air temperature at the plenum, not at far registers, to get an accurate delta T. For cooling, use the manufacturer's expanded performance data to obtain sensible capacity at current indoor wet bulb temperature, outdoor dry bulb temperature, and airflow target. Do not assume total capacity equals sensible capacity. If you lack full data, a field shortcut is to measure total external static pressure, plot the blower fan speed on the blower table, and cross-check with the temperature rise calculation to validate cubic feet per minute. Lock blower speed taps or adjust variable speed profiles to meet the airflow target per ton, then recheck temperature split and humidity to confirm results. Balance dampers at the trunk branches to correct room level high and low airflow without forcing total system airflow out of range. Always re-verify refrigerant charge or heat output after airflow is corrected, because charge and combustion tuning depend on correct cubic feet per minute. One of the most common heating, ventilation, and air conditioning airflow mistakes is setting cubic feet per minute per ton too low in humid climates, thinking it improves dehumidification, which causes coil icing, high superheat, and poor energy efficiency. Fix it by starting near 375 to 390 cubic feet per minute per ton, verifying sensible heat ratio, and adding a reheat or enhanced dehumidification mode rather than starving airflow. One of the frequent issues is trusting supply register temperature instead of plenum temperature for delta T in the temperature rise formula, which skews airflow calculation due to duct heat gain or loss. Fix it by measuring at the air handler cabinet, using proper probe insertion depth, and insulating test points to avoid radiant error. One of the top search engine optimization topics tied to airflow is misreading the blower performance table by ignoring total external static pressure from a dirty filter, restrictive grill, or undersized return. Fix it by measuring static pressure with a manometer at the return and supply, cleaning or upsizing the filter to a larger media cabinet, adding return air pathways, and targeting a total external static pressure that keeps you on the blower curve where your selected speed actually delivers the desired cubic feet per minute. BigHomeProjects.com helps homeowners find trusted local heating, ventilation, and air conditioning contractors who can measure cubic feet per minute, set airflow per ton, verify static pressure, and tune systems using the temperature rise method backed by manufacturer data. Contractors use BigHomeProjects.com to reach qualified customers, showcase certifications and reviews, and win work for airflow balancing, duct design, and system optimization that improves comfort and energy efficiency.